Hi, welcome to this video on equivalent expressions. So here we are in lesson 4.2, and we have this example 1, which is worked out in your book, so I'm going to try to walk you through this example. The student council has $300 to spend on supplies needed to sponsor a dance concert fundraiser. 3 student council members wrote the following expressions to represent the total amount raised for the tickets sold. Can they all be correct? Okay, so here's the thing. They've already spent the $300. So let's try to think about this if we were going through this problem. They're going to use the money that they raised from selling the tickets to help pay for the supplies. Okay, so the money that they raised from the tickets, that's money they earn, but the $300 is money they spent. So whatever money they earn, they're going to take away the money they spent. Okay, so let's imagine this for a second. Let's say, for example, they have 20 tickets that they sold. That's not very many, is it, for the whole school? But let's say they sold 20 tickets. If they're selling them $6 per ticket for 20 tickets, that means that they would make $120. Now, if they made $120, would they have enough to cover their expenses? No. Now you might say, well, where'd you get the 20 from? I literally made it up. So let me make up another number. Let's say instead they were able to sell 100 tickets. Okay? If they sold 100 tickets, remember they're getting $6 per ticket. That would be $600. Would that be enough money to cover their expenses? Yes, because they sold more tickets than they spent. Okay, so let me go another number. Let's say something, we say more than 20, less than 100. Let's say it was 80 tickets. So now let's pretend 80 tickets. So let's say they sold 80 tickets for $6 a piece, and that would be $480. Okay, that makes sense. That's the money they earn. Well, they've already spent $300, so they would have to take the money they earned, the $480, and subtract from that $300, and that would be $180. So then, hopefully that makes sense to you, let's look at these different expressions and see if any of them make sense. So if we're using the letter T to represent tickets sold, then what you see here in this math, it's saying we're going to take 6 times the tickets sold. In this case, remember we said 80, so 6 times 80, and then subtract 300. Well, that's exactly what we did here in our work. So that works. These are just different names for the stuff. So this is the expression we use. The question is, are the other expressions, they also work? So in this problem here, it's saying 6 times t minus 50. So we're not really sure why we're subtracting 50 instead of 300, but would this work? Well, let's try it with the 80. If I say 80 tickets minus 50, then that would equal 30. So then I would have, inside here is 30, so 6 times 30 is 180. So this expression here would actually work. And this is an example of the distributive property. Now, how does that make sense that I'm taking the tickets minus 50 and then multiplying by 6 and that works? It all has to do with the fact that it's a factor, but we also know that we can just multiply 6 times t minus 300, but that's the same thing as saying, well, at the beginning we were in debt 300, and then we're going to get out of debt by adding this money that we made for these tickets. And that's actually going to be equivalent too, because 6 times 80 plus negative 300 is also going to equal 180.